specific settings. Okay, and here we go. So we'll get started just in 1 minute. Hello, everyone. Welcome back here on day 2 of our IRIS-HEP Analysis Grand Challenge Tool Workshop. We're happy to see you connected again today, and we have, I think, a quite exciting program for today as well. We'll have 2 different parts of the day. Before the break, we'll have a common session where we'll be talking about a few different things, and then a small discussion session afterwards. And then after this break, we're splitting up into 2 experiment-specific sessions. We have an Atlas and a CMS dedicated track. The sessions will be happening on different Indico agendas, which are linked on the general agenda. So please check out the experiment-specific agendas from there, and you will find the Zoom rooms for those experiment-specific sessions also linked then on those agendas if you just follow the link. As a reminder, like yesterday, we're going to be happy and encourage you to be using Slido to ask questions. We're sending the link also here in the Zoom chat for your convenience in a second. And with that, I think that's enough introduction. Let's get started with the first contribution today. And the first contribution is going to be about Skyhook. And Carlos, I can already see you're connected and you're here. Carlos will be taking us through Skyhook. Please take it away.
Thank you, Alex. Can you hear me?
Yeah, I can hear you well.
Awesome. I hope everybody can see me too. Yeah.
Right. Yes, I can see you. Just to say, I don't see slides or anything shared yet.
Okay. Yeah. Hold on. Let me get that ready. So.
Yeah, I can see your screen.
And then I will try to do this.
Perfect. Thank you.
All right. So yeah, thank you so much for giving us time to talk about Skyhook data management. And I need to unfortunately apologize. We had through a perfect storm of circumstances, we are actually unable to give you a tutorial, a hands-on tutorial, because first of all, we unfortunately didn't get Skyhook deployed in time at a facility that we can all access. And then the other thing is that Jayjeet, the student who did most of the work, Jayjeet Chakraborty, has been really sick this week. So I was actually trying to sort of pull together something very quickly last night. And I will, unfortunately, it's mostly slideware and a little bit of an old Jupyter notebook that will give you hopefully a sense of what Skyhook is and how it fits into the overall project and how it can play a role in the Analysis Grand Challenge. So, let's see. Yeah.
Will the notebook be available at Coffee Casa site?
Yes. So the notebook is actually already available since February. It's in part of the Coffee. It's actually part of the Coffee GitHub repository. So it's already checked in. The link is, I will put in the link at the very end. We're working on a new demo, but again, we didn't get it done by this time. So
let me just clarify in case it is not available on Open Data Coffee, Casa, because it was requiring to have only Kubernetes deployment, which we don't have. So maybe next event that we will, it's definitely the first one, next event that we will organize, I think we will have everything ready. My apologies, Carlos.
No, yeah, no worries. And, you know, things are sometimes, it was just a lot of unfortunate circumstances. And I really apologize that we don't have something for you ready, because we're really excited, and we have actually, but I will get into the details in a moment. So what is Skyhook data management? It's also actually sometimes called Skyhook DM or just Skyhook. It's basically it's now actually part of Apache Arrow, which is a columnar memory format for flat and hierarchical data, and a large ecosystem of mapping table data, tabular data in a columnar fashion to various devices, you know, whether it's storage devices or GPUs or FPGAs. And it's very fast, has zero copy semantics. And we're very proud that we actually got Skyhook as part of that, and it will be part of the release of 7.00. We didn't quite get it in for the upcoming 6.00, but the next release, which is basically 2 months away, it will be in there. What it does is it offloads Apache Arrow scans into a storage system. So scan is essentially the way you can query data. And a scan can do selection, projections, and it's, you know, it's a very useful thing to go over data. And in Skyhook, we actually offer the dataset, the Apache Arrow dataset interface, and that actually is compatible with root data. The main benefit is that it actually reduces client-side resource utilization. So by offloading these scans into the storage layer, we save resources on the client side, and that becomes more and more important as network speeds become faster. Because the faster the network, the more CPU and memory bandwidth is used to copy data. CPU and memory bandwidth has to keep up with those fast networks. And if we can actually reduce the data before it even hits the network, that's really good. It's particularly good for data-intensive selection operations. What I mean by that is that when you would need to either load a lot of data to make the selection, or you need a lot of metadata to make the selection, you're best off to just do that selection on the server side. A good example is when you do projections, right? Then you want to only have a few columns, then the projection is actually pretty easily done on the client side, because you have, even if there's only 1,000 columns or even 10,000 columns, 10,000 is a relatively small number, and you can easily represent that as metadata on the client side. And so you can very easily project from the client, and you prevent basically right away that you know where that data is, right? So it's basically, you just need to know sort of the basic structure of a table, and you can very quickly figure out what parts of the file do you need to read to actually only get some columns and not others. A different story is if you have billions of rows, then actually selecting rows, you would have to either scan the data, go through all the data, so you would read most of the data, or you will have to have enough metadata, like an index, to actually know where to start reading, right? And so that's exactly what I mean by a data-intensive selection. That is actually something that you're better off, especially when you have high selectivity, or meaning that you want to only have a very small amount of data selected from the entire data set. You want that be on the server side. The other thing that's really cool if you can offload data management to storage layer is that storage systems actually have, and especially file systems, are known for their magic numbers. So if you look at applications and how they access files, the file system interface is really, really simple. The same with object interfaces, right? They're very simple. You have a name, and off you go. It turns out that that the performance of how you access the data hugely varies in the way you do it. And there is basically, everybody knows about random access versus sequential access, which can be, especially when you have spinning media, orders of magnitude different, but also what offsets you actually access the data at. So if you do like 1K or 2K or maybe 4K or maybe 1 megabyte, right? These numbers really matter, and they can be, again, orders of magnitude differences if you like just 1 byte off in terms of performance. And to know these numbers, they can vary from storage system to storage system. And I know HPC applications where they have, spend a lot of time trying to figure out what are the magic numbers for a particular storage system to optimize that performance. Another way to do this is to just say, we actually know what the data looks like on the server side, and we can actually be intelligent about it and hide those magic numbers from the application, so the application doesn't have to know to get actually really good performance. And so this is another reason why we're working very hard to get some semantics into the storage layer, so that the storage layer can optimize for these kinds of cases where it can actually decide how it actually stores and retrieves data from storage devices. And these storage devices can differ, right? In the future, we've seen already big differences between spinning media and flash devices. There are new storage devices coming on. There's also the idea of computational devices, and there are various startups already offering them. Well, Samsung is not exactly a startup, but it's also offering computational storage devices. And so there is a greater variety of storage devices, and applications shouldn't have to learn how to interact profitably with these devices every time a new kind of device comes on the market. It should be actually hidden. It should be the job of the storage system to figure this out, and not every application that uses a storage system. Anyway, so to the right, you see a little barcode. There is basically, this is the blog post that Jayjeet posted a few days ago. And we're actually working right now with the Apache Arrow community to also put together a blog post on their website. They're very excited to have us, and I think this is really cool, because now we actually Skyhook is now can use the same maintenance framework as everything else in Apache. It gets nightly tests. It's there's this whole maintenance and CI pipeline that comes with it, with Arrow, with the Arrow project that we can now take advantage of. By the way, if there are any questions, please interrupt me. I'd be happy to answer the questions in line. So how do we implement Skyhook? I just talked a lot about Apache Arrow and a sort of a general storage layer. We implemented this in Ceph as a plugin. And this is, Ceph has this really nice feature of what it's called CLS. The CLS actually doesn't stand for any, it's not an acronym, it's just a short for class. and it's really an object class. And so Ceph has, it's an object storage system, but it has this cool feature that it allows you to extend methods on those objects. And there's been for many years, and it's actually part of CephFS, for instance, there are methods, special methods available for objects. And it's essentially just you can think of it as that storage servers basically load dynamically load libraries, and you can basically load in, if you know how to do this, any kind of dynamically loaded library and make it available for objects. And so there's this, there are, various applications that have, and that are various interfaces or storage servers that take advantage of this. It's very popular because it actually reduces overall complexity of the system. If you can create methods that are directly associated with the data, you can actually often save a lot of coherence, overhead, and just access semantics that become a lot simpler. The part that Skyhook that implements Skyhook is a tabular object class, and that means that because we could entirely encapsulate the Skyhook functionality into this extension mechanism, we don't need any Ceph modifications. It inherits all the properties that the Ceph is famous for, good and bad, hopefully good and better in the future. It can use all the other object extensions are also available, but it also means, and I want to stress that here, that Skyhook is not a database. It allows tabular access, but it doesn't implement cross-object transactions or any of the things that you are used of a database, right? It basically just allows you to push down certain data operations into the storage layer. We're working on a number of features that are sort of like a database, but we never intend to actually become a full database. Oh, and I should say that funny thing on the left side, this ribbon, that's actually the entire tree of the source code of Ceph, right? And this is basically the cutout is just the part that looks at the extensions, and so you can think of this as like a very small part of the entire Ceph system. So how does Skyhook fit into Coffee Casa? And so I just stole this picture from I think those were Oksana's slides, and there's basically you can see the Jupyter Hub, the Kubernetes resources, including the Service X, Xcache, and Skyhook sits sort of at the side of Service X, and is essentially a data caching facility. So when data gets accessed through Service X, the data gets cached in Skyhook. But because of the abilities to perform selection projections, we can also implement some form of database caching. We still don't have that, but I think we can simply by sub-expressions of Castle, we can easily figure out whether something is in Skyhook or not using digests. This is a technique that various databases use in database caching. And there are actually very interesting ongoing projects that are similar to Castle. There's one that's called substrate. That's like the straight of, like the road straight. So STRAIT. So substrate.io, that's a new effort to standardize data operations. Similar to Arrow, what Arrow did for columnar data, they want to do the same thing for operations on data. And that's exciting because if that becomes sort of a standard, just like Arrow becomes for columnar data, then you will be able to take these digests, and they're basically standardized on sub-expressions. And so these sub-expressions then become truly, the same for across different systems. So as long as you have an interface that is have a standard way of querying, on the query plan level, you can actually create sort of universal digests for the same amount of content or the same kind of content. Not based on content, but the query, the same kind of query. So this is a very new effort. And I think until Substrate really becomes mainstream, we can use Castle, and that would allow us to, look whether a particular query, a part of the data that's already cached, can be found on Skyhook. Then the other thing that, as I said, we are going to implement next is a persistent data views. So when you actually, right now you can, you can store tables, but you cannot actually define views over those tables. You just have to store a table, and then that's your table. And we want to also have friend tree management, which means that essentially this is directly related to views, right? So that data that is essentially doing the systematics of a data set can be viewed together. And we want to do selection by trigger bits. So this idea is that you basically encode certain properties in bits and have that as a column. You store that with the data, and then you can very quickly retrieve that just looking at these trigger bits. So that's how Skyhook fits in, and I'm gonna, if there are no questions, and we can also discuss this later, I'm gonna dive in a little bit of how Skyhook actually works. So on the left side, we have the client, and on the right side, we have the server. So there can be many clients, and there can be many servers. And the only thing that's actually Skyhook specific is the green part. The orange part is directly from Arrow, even before Skyhook was merged into Arrow. And everything else is just pure Ceph. And so the extension mechanism of Ceph allows us to embed Arrow and a file system shim into the object context of the object store. And so there's basically, you don't have to modify Ceph at all to get Skyhook to work. So let me just walk through it. On the left side, you can have an application that's maybe a Dask worker that links to the Skyhook interface. And there's on the top level the dataset API. That's the Apache Arrow dataset API that allows you basically to have tabular access on a set of files. And then there's the Arrow library underneath that that basically implements the dataset API. But the extension of Skyhook allows it to dedicate any queries that you want to perform on that data set can be then delegated through the Ceph client to the Ceph storage server. So that's the change, right? So and the way this works is that the green part knows about the mapping between files and objects. In Ceph, you can just configure, and say that each files get mapped, let's say in 8 megabyte chunks, right? Files have 8 megabyte objects, and that means that no object can be larger than 8 megabytes. And basically the first, depending on the striping strategy, but that's also known by the green part, the first 8 megabyte of the file is an object 1, and the second 8 megabyte of the file is an object 2, and so forth. And you also know how the objects are named, right? And so you know what object 1 is named based on the file name, and what object 2 is named based on the file. So this is all the knowledge you need to, when you then write Parquet files, we have a splitter that splits the Parquet file into these objects, which basically just files that get stored on CephFS. These, we know then that each of those files map exactly to one object. And then for Skyhook, when we actually query, we bypass the Ceph file system and query those objects directly. And since this is read-only, there won't be any trouble with updates, right? So this is not dangerous. We just know that as soon as a file exists and it has this particular mapping between file and objects, we know how to query those objects. And that's pretty much it. And the beauty of it is that every time, let's say, Arrow gets updated, right? It's very easy to also update Skyhook and Ceph because we don't change anything in Arrow to get this done other than this delegation on the client side. On the server side, because Arrow operates on file systems, right? It has extensions like Parquet or other file formats that come with Arrow. We give Arrow the illusion when it runs within an object that it is actually operating on files. And so it has a file system shim. It's a very thin layer that is also part of the Apache Arrow, which we inherited from their interface to S3. And it turns out that we could very easily extend that layer to actually have also to have this illusion of files of a file system on top of the object store. What I want to point out is that that this file system shim is above the redundancy layer, which means that any failure, any physical failure, like a storage node goes down or something, that won't affect the setup because objects get just remapped to another server, right? And so all the and this is all this remapping. Sorry, all this remapping is handled by librettos on the client side. So if a storage server suddenly disappears, it gets there's just a little delay, and then immediately there's a retry to a different server. So this whole setup is inheriting all the robustness of a storage system. So it's time for a quick example. So let me see. I think I need to stop sharing, or maybe not stop sharing, but I need to.
You have about 3 minutes left, so we can take a quick look at this. But just to let you know, we have about 3 minutes.
Okay, great. So let me see whether I can find my window again. So I think this is it. So basically, the way you set this up is you load PyArrow. There's a number of data set and PyArrow parquet, and then the only difference is that you basically use this new method of Rados parquet file format that's actually called now Skyhook file format. You give it a Ceph configuration file. That's a standard Ceph configuration file that just tells it where things are, and then you can name a data set. You tell what the format is. You also said it's the the Skyhook file format, and then everything else is pretty much exactly the same, and that includes when you use a coffee processor. There's you can do all the same things that you could have done with a data set. That processor exists, and but there's so many things that change in coffee. We have to actually adapt it to those changes, and that was what Jayjeet was going to do this week, but he unfortunately fell sick and we just couldn't get it done. Yeah, that's it. Thank you so much.
Thank you very much for this overview. It's fascinating to see some details as well, and I'm looking forward to seeing this integrated with our other tools. There's one question currently on Slido. It would be interesting to know if you have already some preliminary performance measurements of Skyhook.
Yes, we do, and in fact, that's we spent a great amount of time on understanding exactly the performance, and so right now. The selection, we are better than Parquet. We always compare our performance with vanilla Parquet files, right? So we are significantly better than Parquet performance when it comes to selection. When it comes to projection, we are about the same. One of the key challenges is the serialization overhead that we introduce on the server side. Because when we touch the data on the server side, we have to repackage it. So even if we select down the data, if it approaches a low selectivity or like when there's a very little reduction of the data, then we are actually getting worse because you actually unpack the data and then repack the data and you send the same amount of data anyways, right? But if the selection is, I think the crossover is about 50%. When you select less than 50% of the original data, we're actually a lot faster, and that gets even better when we have even more data reduction. But it's row-based selection that really is the killer. Column-based selection, not so much.
Thanks. Yeah, that sounds very promising. The other thing I was wondering is how much the sort of end user experience may change by like the integration. But as the notebook I think shows, that for the end user, things will look very similar. So it's not that like any huge adoption is needed, which is of course great.
Yeah, and then there's going to be new ways of doing things. For instance, we can actually write back data and we can organize data in a way that that allows you to actually don't have to copy tables again and again, but you can just add columns and keep things more organized without wasting a lot of storage space. That's the key promise.
Okay, thanks. Jim, you have your hand up. Do you also have a question?
Yeah. First, a comment. Congratulations on integration into Arrow. That's awesome.
Thank you.
And actually, it's good timing. And in Awkward Array version 2, the minimum version of Arrow is either going to be 6 or 7.
So, hopefully 7.
Yeah, well, actually, why not?
Yeah.
We can pick it based on if there's if if having Skyhook in Arrow 7 means that it will be easier to install, if it's going to be pip install PyArrow, and then we get a large part of it, and then we just need to somehow hook it up to the storage, then that's a really killer app.
Yep.
Really good reason to take 7 as a minimum. So actually, how much setup is there? Like, suppose that you pip install PyArrow 7. What's left? How much more do you need to do?
So there's a workflow to actually install the plugin on Ceph, right? And so in order to actually make the plugin available in Ceph, you will have to copy binaries into every storage server into a particular directory. And that's it. So there's a workflow that, that will be part of the Skyhook distribution that actually does that. There are also going to be tests. And so, but yet once you have that, then the client, works, because you can just throw method calls onto Ceph, right? You don't need to actually register anything on the client side. And the server will look for the symbol on the in the shared directory, or in the shared library directory. And at the beginning, the first time it takes a little longer, but once it actually figures out, oh yeah, there is the shared library that resolves that symbol, I'm good.
Okay, yeah. So then I could say that the advantage of being in Arrow and then taking Arrow 7 as a minimum is that it becomes easy to set up clients. For setting up the server, of course, there's always stuff, but anyone could get started and up and running on this with just pip install PyArrow.
Exactly, and so so once you have that workflow, the workflow has to not be executed by the client or by the user, right? The workflow has to be executed by the person who deploys Ceph, and so that only has to be done once. Yeah.
Right.
Or when you want to upgrade them to the next version.
Okay.
Okay. Thank you very much once again, Carlos.